mentioned, things can get a bit more difficult when you're dealing with absolute values in conjunction with exponents or inequalities. So I'm going to show you a few examples of slightly more difficult applications of it. All right, so in this case it says absolute value of 6 minus 5x is greater than 30, which of the following is a possible value of x. Now, it's important to remember that with absolute values, the number on the inside has to have some characteristic that relates to the rest of the inequality. In this case, the number that's on the inside has to be, once you take the absolute value of it, greater than 30, right? Which means that I can just get rid of the absolute value sign because I know that this number has to be greater than 30, right? So I can do 6 minus 5x is greater than 30, right? And then just solve for x, right? Subtract 6 from both sides, I get negative 5x is greater than 24. And then x is, I have to flip the sign because it is divided by a negative number, 24 over 5, right? Negative 24 over 5, which is, let's see, 4.8, negative 4.8, right? And then I say, well, it also has to be that the number here has to be greater than 30 when I take the absolute value, but therefore it could be, you know, negative. It could be negative 31, negative 32, negative 33. That is, the number itself has to be greater than 30. So the way you deal with these situations is you get rid of the absolute value sign again on the left-hand side, but you flip the inequality sign, and then you flip the sign of the other side of the inequality. So in this case, it's 6 minus 5x is less than negative 30, right? And I solve for x the same way, right? So subtract 6 from both sides, get negative 5x is less than negative 36. We get x is greater than, see, 7.2, right? And if we look at our answer choices, we know that x is less than negative 4.8. That doesn't really help us with much. Then x is greater than 7.2. The only answer that works here is E8. Okay, so for the second question, it asks you to compare the values of the function with the actual input, right? So in this case, they want to know for what one possible value of a is the overall value of the function less than the input itself, right? So in this case, we know that the function f of a is the absolute value of 3x minus 17, right? And they want to know when is that less than, in this case, they'll use a. It doesn't matter, as long as you have the same variable. So 3a minus 17. And again, we do the same thing here, right? So we can just drop it and solve for a. Move the a over here to a, and then move the 17 over. 17, a is less than 17 over 2, right? That's a lot of numbers though, so we have to make sure that we do the other one, right? So again, it's 3a minus 17 is greater than negative a, right? So in this case, that's 4a is greater than 17. A is greater than 17 over 4, right? So we can use our calculators to get decimal equivalents, or we could just sort of pick a number that's between these two. But we'll do the calculators to be thorough. So 17 over 2 is 8.5, obviously. And then 17 over 4 should be 4.25, but let me just double check. Yeah, 4.25. So any number that's between these two will be a correct answer. So we'll just say 5, because 5 is a good number. That's it. Okay, make sense?